Hey everybody, it's Kyle at myersmathematics.com, and it is summer. Yes, amazing. I was thinking, instead of doing a series or something, I was starting to do a series on factoring maybe towards the end of the year. But I'm thinking I'm just going to do a couple random neat little tricks that you might want to know that might be helpful over these couple summer months till we get back, and then I think I'm going to start a whole unit and just go through a whole unit either in an algebra topic or geometry, or I might just follow through with the whole course as you're taking whatever class you're taking. High school math is usually what I focus around, but I'll be making more topics in the future. So today I want to show you a little trick. It's on divisibility. Divisibility. Right, so that's the topic for today. So you're thinking, oh, well, what was that again? I forgot what that was. It's basically just when you divide things, right? So when you divide things, if you can divide something so that the answer is not a fraction or a decimal or something like that, then it's considered divisible, right? So I guess I'll kind of write down a working definition here. So if it's divisible, right, then that means that you have two, we'll say integers maybe, or whole numbers. We'll just say whole numbers because it doesn't really matter if it's positive or negative. All right, so two whole numbers that can divide to get another whole number. So that's basically what it means to be divisible, right? So it's actually really useful to find out when things are divisible, like if you need to simplify a fraction or something, right? So for instance, 6 over, oh, you know what? I broke my other rule. I like to use green, for example. So let's use green, for example. Oh, sorry, that 6 didn't come out that well. All right, so 6 over 3. Well, if you've taken first grade math, no, it's been a while. If you've taken, let's just say first grade math, then you should know that this is 2, right? So 6 over 3, that's 2. That means that it's divisible. That means 6 is divisible by 3, and it also means, conversely, that 6 is divisible by 2, because 6 divided by 2, well, 6 divided by 2 would just get me the other thing. It would just get me the 3. It's like I switched them around. So 6 over 3 is 2, 6 over 2 is 3. That means that 6 is divisible by 3 and 2. Oh, and of course, I'll just throw this in here, but obviously it's also divisible by 1, because any whole number is divisible by 1, right? If you divide it by 1, you're going to get the same number, right? Dividing by 1 rule. So with that in mind, I'm actually going to skip the one trick, because it's anything divides by 1, right? So what I mean by the tricks I'm going to show you. I'm going to put a little thing in here. So here's what I mean. If I can spell right, goodness. If it goes into blank, right? So if it goes into blank, then the trick is blank. That's kind of the idea here. Let me make that a little bigger. Let's blow that up a little bit. Okay. So if it goes into blank, then the trick is blank. So here's what I'm going to do. I'm going to do a circled number. I'm going to tell you what the trick is. All right. So 2. We're going to start with 2 because we're not going to start with 1 because everything goes into 1, right? Everything is divisible by 1. 5 divided by 1 is 5. 6 divided by, did I just say 5? 5 divided by 1, yeah, I said it right. 6 divided by 1 is 6. 7 divided by 1 is 7, right? You can go do that all day. But 2's, not everything goes into 2. Just, approximately half of the things, right? So the 2's trick is actually pretty straightforward. You probably already know this. It has to be even, right? It has to be even. Meaning it ends in 0 or 2 or 4 or 6 or 8. And that's it. If it ends in 1 or 3 or 5 or 7 or 9, then it's odd. So it doesn't go into 2. So that's it. That's the trick for that. All right. Now, here's where it gets interesting. This is the one that you probably haven't heard of, unless you've been tutoring with me, which you can do if you live in the Tampa area around USF. You can go on my website, myersmathematics.com, book a session, and if you book a session through there, I usually give you your first session for free, and also give a referral bonus. So lots of free stuff out there. But anyways, the trick for threes is really cool. So I'm going to use slightly technical language maybe, and then I'll use an example to make it make more sense. So if you take the sum, right? I'll just say add. If you add up the digits of the number, right? That's not a hashtag, it means number. Add up the digits of the number, and it goes into 3, then the number goes into 3. Number goes into 3. It's a much longer description than the 2. The 2 is super easy. All right, so example. Let's do an example. Okay, so add up the digits of the number, and it goes into 3, then the number goes into 3. So let's see here. So example. All right, so give me a number between 1 and 10. Oh, 2? All right, cool. Let's use 2. And then 4. And I don't know, 0. We'll do 2, 4, 0. Okay, so we add up the digits. 2 plus 4 plus 0. Oh, that's 6? Oh, thanks. All right, so 2 plus 4 plus 0 is 6, which goes into 3. We actually just looked at an example of how 6 goes into 3, right? So 6 goes into 3, right? So that means that 240 goes into 3, right? And you could divide it and find out, right? So 3 goes into 24 8 times, and then you add a 0, so it goes in 80 times. But these tricks are really just to show you how to, knowing that you can divide. So this is especially useful if you have a calculator, because then you can just type it in, right? But you still need to find out. But even if you don't have a calculator, it's super useful, because otherwise you could just take out your calculator and be like, oh, does it divide by 2? Oh no, I got a decimal. Does it divide by 3? Oh, I got a decimal again. You could just do that. The fourth trick is a little bit, probably one of the most complicated ones. It has to be even, right? And that's because 4 is just 2 times 2. And then there's actually kind of 2 different ways you could find out if it goes into 4. So if it divides by 2, and then the answer is even. The answer is even. All right? So if you divide it by 2 and then the answer is even, it goes into 4. Okay, so let's look at an example of that real quick, and then I'll show you the other trick. So, por ejemplo, for example, let's say, we'll just, why don't we just use 240 again? Why not? It's working just fine. All right, so 240 and divided by 2. All right, it is even. All right, so let's divide it by 2. If I divide it by 2, just take half of all the individual digits is a little trick you can do. So half of 2 is 1, half of 4 is 2, half of 0 is 0. So 120. And look at that, 120 is still even. 120 is still even. So since it's still even, right, 120, which is even, so So 240 is divisible by 4. There you go. So you can divide it by 4. And if you were wondering, it'd be 60. Okay, and then the other trick. Right, so here's the other trick. So look at the last 2 digits. That's another trick. Look at, and we actually could have done that on the 240. If you look at the last 2 digits are 40. Look at the last 2 digits. Okay. And if those, meaning the last 2 digits, go into, ooh, that was a sloppy into, oh well. If those go into 4, then the number does. Right? And you can kind of see that with the 240. We already know that it goes into 4, but we can check it because the last 2 digits of 240 are 40, and 40 is 4 times 10. So of course 240 has to go in. It could be 340, it could be 440, it could be 5,257,340. And that would go into 4 because the last 2 digits go into 4. Doesn't matter about any of the other digits except for the last 2. Okay, another little trick there. All right, so for really big numbers, it's still just as easy to find out whether it goes into 4. And then another little thing is that this is not something I'll write, but I'll just kind of mention because it's not that useful. But if you notice, there's also a little pattern with the odd and even of the digits. So like if you count by 4s, you go 4, 8, 12, right? So then it goes into a 2-digit number. But if you start at 0, like 0, 4, 8, all right, well if the tens digit is even, right, then the ones digit would have to be a 0 or a 4 or an 8. Then if the tens digit is odd, then the ones digit would have to be a 2 or a 6. And that happens over and over again. So if you count by 4s, you get 4, 8, 12, 16, 20, right? 12, 16, and then 20, 24, 28, right? 0, 4, 8, 32, 36, right? So 2, 6. And that pattern just repeats over and over again, right? So kind of not that useful, but that's why I didn't write it down. It's just, if that sort of thing intrigues you, then, take that and run with it if you want. Right. 5's trick, there's not really a trick, it's kind of just common knowledge. It ends in 5 or 0. I don't even need to put an example for that one. It ends in 5 or 0. That's it. And there's actually kind of a 6 trick as well. And it's not so much that it has its own trick, just that I'll say a number. So the number goes into 2 and 3, meaning that the 2's trick, the 2's trick and 3's trick work. 2's trick and 3's trick work. Right? So meaning it's even, it ends in 0, 2, 4, 6, or 8, and the 3 thing works. So actually we can use 240 for an example. Right? So 240 is even, and if I add up the digits, it's 2 plus 4 plus 0 is 6, so it goes into 3. So it goes into 2 and 3, which means 240 goes into 6. So there you go. There's no 7's trick. Right? 7 is just ugly. Ugly. No tricks. All right, there's no tricks to being ugly. All right, and then for 8, I'm going to put for that one because it has to be even, right? And it obviously has to go into 4. right? But it has to go in again. So the only trick really for 8, if we look back at 4, we saw that you can divide it by 2 and then the answer is even. Well, here we can say divide by 2 or half it, right? You can take half the number twice, right? So take half of the number and then take half again, divide it by 2 and then divide it by 2 again, or just divide by 4 if you already know what that number divided by 4 is. So if you take half the number twice, then the answer is even, right? Then the number is divisible by 8. It's really the only trick. It just, 8 is 2 times 2 times 2. So, I mean, it was easy when we were back at 2s. It's even, whatever. But 8 is a little bit more complicated. It's just, it is what it is. And the whole 2 digits thing doesn't work for this either, right? So if the last 2 digits go into 8, that doesn't necessarily mean that it goes into 8, okay? That trick doesn't work either. I mean, technically the last 3 digits, but that's a little much. So that's pretty much all I'm going to say for the 8. The 9, though, a little light at the end of the tunnel here. The 9, so let's go back to the 3 real quick. The 3 trick said add up the digits of the number and it goes into 3. Then the number goes into 3. Okay, so we add up the digits, all right, 2 plus 4 plus 0 equals 6. And then that went into 3, so it went into 3. It's the same thing. 9 is the same thing. Same thing as 3 trick, right? Meaning same thing as 3, but not like word for word, right? So if it goes into 9, right, if the sum of the digits goes into 9. So let's look at an example. So for example, let's do 243. Okay, so 2 plus 4 is 6, plus 3 is 9, right? 9 divides by 9, right? Gives you 1. So since 9 is divisible by 9, so 243 divides by 9. There you go. And it works with everything. 333, right? 3 plus 3 plus 3. Or it could even be something that adds up to like 18. Like 675. Yeah, 675. If I did 675, I add up all the digits, it adds up to 18, and then divide it by 9, and you get 2. So there you go. All right. And last one, the easiest one, actually. We're ending with the easiest one. You guys know this. If it divides by 10, then it ends in 0. And actually, fun fact, because it ends in 0, well, I shouldn't say because it ends in 0, because 10 is actually 5 times 2, right? It's sort of like the 6, right? The 6 trick is that if it goes into 2, if the 2's trick and the 3's trick work, is what I put in parentheses here. Well, the 10 is basically 5 times 2, so it's the 5's trick and the 2's trick, right? If you combine the 5's trick, it has to end in 5 or 0. With the 2's trick, it has to be even. Well, between 5 and 0, 0 is the even one. So there you go. That's the whole reason, among others, I guess. And those are all the divisibility tricks. That's it. That's all of them, right? So now you are prepared to tackle any number. You can simplify any fraction. You can, change form, or you can, I don't know, all the things. Usually it has to do with fractions. Like if I had a big fraction, I wanted to simplify it. So actually, let me do one example of that. So let's look at that. So let's say 24 over 64. Okay, so they're both even. All right, so I know they both go into 2 at least. 2 plus 4 is 6, so it goes into 3. 6 plus 4 is 10, so it does not go into 3, because 10 doesn't go into 3. So it does not go into 3. It might go into 4, right? And actually, since I know my numbers fairly well, I do know that it goes into 4 just by looking at it. But you might not at first. So let's just divide by 2. We know it's even. We'll start with that. Divided by 2, meaning take half of it. So 12, half of 64. So half of 6 is 3. Half of 4 is 2. Right? And look at that. They're both still even. So let's just do it again. Divide by 2. Divide by 2. That equals. So half of 12 is 6. Half of 32 is 16. And they're still even. Look at that. So half of 6 is 3. Half of 16 is 8. And that's as far as we can go because 3 is a prime number. And 8 does not go into 3. So we already established that 64 does not go into 3. So if you divide it by things, it's not going to result in something that's going to, be divisible by 3 all of a sudden. So there you go. Right, so we used our divisibility tricks. All right, and if you use the 4 trick actually with the whole thing I mentioned but didn't write, both of these start with an even number and end with a 4. So that's the other way that you know that they go into 4. Right? If it starts with an even, if the tens digit is even, then the ones digit would either have to be a 4 or 0, a 4, or an 8. Right? And it is. So there you go. We just divide by things. You're welcome. This has been Mr. Kyle at Myers Mathematics. Over and out.